Hello viewers, you are welcome to this tutorial. So in this tutorial we'll be treating triangle theorems. So I divided the theorems into two parts. The first part is basic triangle theorem. Under that you see triangle inequality theorem, Pythagorean theorem, Isosceles Triangle theorem, Asteria Angutirin down to 120 triangle theorem. So while the second part, we have the advanced triangle theorems. So the first one is similar triangle theorem, mid-segment theorem, triangle proportional segment theorem, sine rule, cosine rule, tangent rule. So down to Mowis theorem. So we are starting with the basic ones. So the first basic triangle theorem is triangle inequality theorem. We have triangle for the first. So the first is triangle inequality theorem. Triangle inequality theorem, or you call it the third side rule. So the theorem states that the third side of any triangle is less than the sum of the two other sides and greater than the difference of the two other sides. So it states that the third side of any triangle is less than the sum of the other two sides and greater than the difference of the other two sides. So the theorem, assuming you are given, let A, B, and C be the sides of a triangle. So the rule states that the third side, so let me take C as the third side. So is always less than the sum of the other two sides, which is A and B, is A plus B, and is always greater than the difference. That is, the difference is less than. So A minus B. So let me use absolute value, meaning any one that is greater will be the one to subtract. So, or if you take B to be the third side, so here must be A plus C, and here must be A minus C. So finally, if A is the third side, so it must be less than B plus C, must greater than B minus C. So that's what the theorem states. So example, if you ask, is the polygon with sides 3, 6, and 10 a triangle. So we are asked if this polygon with sides 3, 6, and 10, a triangle. So the only way we can solve this is using triangle inequality theorem. So check any one. So once, remember, the 3 must be satisfied. If any one fails, so it must be satisfied. So this must be true, true, true before it's now true is a must. So let's take 6 first as the test side. So 6 must be less than 3 plus 10, or 10 plus 3, and also 10 minus 3. So I think it's correct. So it's not correct. But this 10 minus 3 is 7, so it fails. No. So the answer is no. Because 10 minus 3 is 7. 7 is not less than 6, so it's not a triangle. So the second theorem is Pythagorean theorem. So the second one is Pythagorean theorem. So Ali, we are conversant with this one. Pythagorean theorem states that the sum of the squares of the legs of a right triangle equals the square of the hypotenuse. So it states that the sum, we're conversant with this. So this theorem is restricted for a right triangle only. And meanwhile, if in any triangle, once you hear leg or the legs, we are talking about a right triangle. It states that, so if you are given a triangle and the side are A, B, and C. So the theorem states that once you sum the square, the sum of the square equals the square of the hypotenuse. The longest side is the hypotenuse. So why the other two sides are saying that these are the legs. YC is the hypotenuse. So that's what the theorem states. So once you are given that, say example, if you are given 3, 4, and you are asked to find x. So since this is a right triangle, we apply Pythagorean theorem. So x squared must be x squared must be equal to 3 squared plus 4 squared, which is 9 plus 16, which is 25. 25 is 5 squared, so x is 5. So that's what the theorem says. The next theorem is Isosceles Triangle theorem. So from the name, Isosceles Triangle. So this is called Isosceles Triangle theorem. So the theorem is for isosceles triangle. It states that the base angle of any isosceles triangle are congruent. So it states that the base angles of an isosceles triangle are congruent or equal. So I'm saying that if you have a triangle, isosceles triangle, that's two sides are equal. That whatever that is here, these are the base angle. So this is the vertex angle. This is the vertex angle. Why these are the base angles? So it states that whatever that is here. So if here is x, here should be x. So the next theorem is Asteria Angutirin. Asteria Angutirin. So it states that the exterior angle of any triangle is equal to the sum of the remote interior angle. So it states that the exterior angle of a triangle is equal to the sum of the remote interior angles. You'll be wondering, what is remote interior angle? So if you have a triangle and here, if here is A, here is B. So assuming this is the exterior angle. So the other two angles that doesn't form a linear pair. So it doesn't form angle on a straight line or linear pair, which C is the remote interior angle. So I'm saying that this is the remote interior angles. So why is this is the exterior angle? So we state that C must be equal to A plus B. So that's what the theorem states. The next theorem is also for exterior angles. It's called exterior angle inequality theorem. So it's exterior angle inequality theorem. So also the name is for exterior, from the name, so it was stated for exterior angle. So it states that the exterior angle of any triangle is greater than the two remote interior angles. So it states that the exterior angle of a triangle is greater than the two remote interior angles. So from that diagram, we are saying that C must be greater than A and C must be greater than B. It's correct because the sum is equal to C, so automatically C must be greater than A and B. So the next theorem is the 45-45-90 triangle theorem. 45-45-90, from the name, the angles must be, that's the interior angles, 45, so we're on 45, 90 triangle theorem. So the theorem is just for it's for right angle triangle. So from the name is for, we have a right angle triangle such that the interior angle are 45. So it states that if here, assuming here is x, here should be x by isosceles triangle theorem, that the base angle are the same. So whatever that is here, which is the hypotenuse, must be x root 2. So x times root 2. So that's what it states. So assuming we are given this 45, and your asked here is 10, and we're asked to find x without wasting time. X must be 10 root 2. So that's what the theorem states. So the next one is 30 30, 30, 30, 60, sorry, 60, 90 triangle theorem. So this one is also for a 90 right angle triangle. So if you have a right angle triangle, so it states that if here, assuming here is 30, here should be 60. So it states that if here is x, whatever that is here, that the one opposite 60 must be x root 3. And finally, the hypotenuse must be double 2x. So I'm saying that if you have 30 degree here, I have 10, without wasting time, whatever that is here must be 10 root 3. And whatever that is here must be 20. That's what the theorem states. So it's direct. The next theorem is 30, 30, 120 triangle theorem. 30, 30, 120 triangle theorem. So this one is a direct implication of 30, 60, 90. Because assuming you have a triangle, this is 120. So assuming you have an isosceles triangle, so meaning whatever that is here. So if here is 30, here is also 30. Meaning that if here is 30, here should be 60, 60. So assuming here is x, the one facing 30. So whatever that is here must be x root 3. And here should be x root 3. And here is 2x. While here is 2x. So if you notice, we'll form a triangle. So what you form, and as this, so which is 120. While here is 30. Here is 30. So here is now 2x root 3. Finally, here is 2x and 2x. So if you notice, what is here is 2x, 2x, and 2x root 3. So the ratio of the sides are 1 is to 1 is to root 3. Because this 2x, 2x, the same here is 1 is to root 3 is to 2. While the first one is 1 is to 1, 1 is to 1 is to root 2. So that is very, very important. That's what the theorem states. So example, if you are asked to find, example, if you are given this 120, and you are giving we are given 30, 30, and we are told that here is 4 root 3. We are asked to find x and y. Without wasting time, x and y are the same because of isosceles triangle theorem, and it must be 4. Because remember, the ratio is 1 is to 1 is to root 3. So for this to be 4 root 3, x and y must be each 4. So that's the end of the first theorem, which is the basic triangle theorem. So let's enter to the next one, which is advanced theorems. Thank you.